In this section, we're going to discuss the binomial distribution and where a binomial experiment is quite common in especially sports like baseball. If you've ever seen the movie um, Moneyball, um, it has Brad Pitt in it, but actually it talks about how baseball introduced the concept of probability and the chances of winning using binomial distribution in baseball, and that's one of the techniques used with the Boston Red Sox when they won some time ago. So binomial distribution is a very widely used concept in many different disciplines. So we wanted to just talk about and start with like, well, what is a binomial experiment or a binomial distribution? So a binomial experiment is an experiment that performs a fixed number of times. So you can't just keep tossing a coin forever. You're only going to toss the coin 100 times. Each repetition of the experiment is called a trial. The trials are independent. So remember when independent events mean when you toss a coin, meaning when you toss a coin the second time, that probability will not be affected by the first. Same with rolling a die. But recall that independence with even a deck of cards, remember we did with or without replacement. And it was just when one event, the second event or following events are affected by the previous events. In this case, we're going to like it because all binomial experiments are independent and each trial is independent. The next thing is that for each trial, there are two mutually exclusive outcomes, success or failure. So even though the event could be tossing a heads when I toss a coin, the success would be the heads and the failure would be the tails. So think of it too as free throws. I always use free throws in basketball as an example because the success is you make the basket and the failure is you don't make the basket. The probability of success is fixed for each trial. So, like thinking about the coin, the probability of tossing a heads is 50%. And if I toss it again because they're independent, it still will be 50% on the second flip. So these are the characteristics for a probability, a binomial experiment. And the notation for the probability distribution function is there are we call n independent trials of the experiment. Let P denote the probability of success so that Q is the probability of failure. I tend to use 1 minus P, but we could use Q as well. And then we let x be the binomial random variable, which denotes the number of successes and independent trials. So again, we have a fixed number of trials, meaning we're going to toss the coin 100 times. The probability of tossing a heads would be the probability of success, so that the probability of tossing a tails would be a probability of failure. X is the binomial random variable, which is when the success is the event of tossing a heads. So just kind of think of it as like a coin toss in the back of your mind. So let's go ahead and use these four conditions up here that we just discussed and determine whether or not these criteria are met and these are binomial experiments. So the first one is the player rolls a pair of fair die 10 times and the number X of sevens rolled is recorded. So again, the random variable X, which is the event that's successful, is rolling a 7. So let's go through the conditions. The first condition, right, would be a fixed number of trials. So it looks like I'm only tossing or rolling the die 10 times, right? So n is equal to 10. So the first criteria is met. And the second criteria is if the trials are independent. So if I toss a die or a pair of fair die 10 times, the first time I roll it, will the second roll be affected by the first roll? And we would say no, that these are rolling a die or rolling a pair is independent, as we know. Okay, so the third condition is for each trial there are two mutually exclusive or disjoint outcomes. So again, mutually exclusive means that the second roll is can't be the same as the second roll, right? Like the deck of cards, like can a heart be a diamond and a diamond be a heart? That's mutually exclusive. Um, right? And so, but if I have a heart and a nine, can a nine be a heart and have a heart of nines? Yes, so that's not mutually exclusive. So here, if I roll a fair die 10 times and sevens are rolled, meaning the sum of the die. So if I just kind of draw a couple of die and have a 2 here and a 5 here, that's 7, right? The sum of the die is 7. So if I roll a 7 in this first trial and then I roll again, let's say a sum of 3, can this happen at the same time? Can I roll a sum of 3 at the same time I roll a sum of 7? And the answer is no. So these are mutually exclusive. And we always recognize throughout the course previously that rolling a die is mutually exclusive as well. And the last condition was when the probability of success is fixed for each trial of the experiment. So is the probability fixed? Well, yeah, if I want to roll sevens, that probability is the same for each roll. Okay, so since all four criteria are met, all four criteria are met, this is a binomial experiment. Now, we usually mentally go through these steps. Like we think, oh, is it a fixed number of trials? Are they independent, mutually exclusive? Is it the same every time I, um, randomly select an object from my sample? And so we mentally do it, but we're writing it down here because it's the first time we've seen it. But really, eventually, these will be like mental steps. So let's talk about the second one, which is airlines. The 11 largest airlines had an on-time percentage of 84.7% in November. In order to assess reasons for delays, an official with the FAA randomly selects flights until she finds 10 that were not on time. So here she's not having a certain number of trials and then observing the ones that were on time from those fixed number of air flights. But she's going to sample until she gets 10. So it's not it's not a fixed number of trials. So here, if fixed number of trials, right? And I would ask you, like, well, okay, so if she's going to randomly select flights until 10 that were not on time, right? Well, how many flights is that? And you would say, well, I'm not sure. And so I would say, okay, well, then that's not a fixed number of trials. So a fixed number of trials says, no, I'm going to look at 30 flights and see which ones weren't on time. That would be fixed. But saying like, oh, I'm just going to like grab flights until I get 10, that's not fixed. And therefore, no, and then it fails the first criteria, and therefore this is not a binomial experiment. Okay, so the last one can be a little tricky, but we'll get through it. Let's just read it carefully. In a class of 30 students, 55% are female. The instructor randomly selects 4 students. The number X females is selected is recorded. So the event of success is when the instructor selects students that we select female. That's the success. Okay, so let's go through the criteria. The first criteria is a fixed number of trials. Yeah, so how many students does she have in her class? 30. So she selects 30, and then the event that's successful would be the ones that she selects that are female. So this means that she has 30 trials, and in those trials, she's going to observe the successful trials, which is selecting female. So then the second part, or the second condition, was independency. The trials are independent. So here we have to remember what independence means, right? It's when the second probability isn't affected by the first. So then we ask ourselves, well, okay, she selects one student. Okay, and when she selects the one student, then how many students are left to select from, right? Then only 29 students are left. Will this change that second probability? So she selects one student, right? So here's the class of 30, and she selects one student and records whether or not that student is male or female, right? And if it's female, it's successful, right? So now there's only 29 left. So now comes the second selection. And then it records male or female. But does that probability stay the same, or is this probability changed? And I think you can agree that it does change because that denominator changes to 29. And so therefore this is not a binomial experiment because trials are not independent. So trials are dependent. Okay, so I hope this helps with understanding what a binomial experiment is and understanding that there are 4 criteria to meet that.